horizontal and vertical lines. We're going to talk about horizontal and vertical lines. Look at that red line that's graphed there. Can anybody tell me what the equation of that line is? It's vertical. The slope is undefined. You're right, but what's the equation of the line? Say it again. X equals -3. Yeah. How come? Look at the yeah. Look at all these points. What we'll find here, if it's a vertical line like this, what's interesting and important about that line is that the x coordinates are all the same, right? The x coordinates are specified. They're -3. The y coordinates could be anything. Do the y coordinates have any connection to the x? No, they don't, do they? It's not like a normal line where if I plug in an x value, I could solve for a y value, right? Like if we go back to some of the previous lines we looked at, we were able to plug in an x value and solve for y and see what the output y value was, right? But here we can't do that. There's no y in the equation. There is no connection. The y could be anything. It doesn't matter, but the x, regardless of what the y is always -3. And for that reason, the math gods name a vertical line by its x coordinate, because that is the part that is specific. The y part could be anything. There are an infinite number of y values on that line. Take your pick of whichever one you want. Whichever one you pick, its x coordinate is always going to be -3 for that line. Okay? Questions on that? Okay. Does that make sense to you when you talk about it in that context? Why, when we name a vertical line, we name it by the x coordinates of every point on the line? Okay. So using that same logic, what would the equation of the horizontal line in number 12 be? Y equals 1. Because again, the y coordinates are all 1. X could be anything, but the y coordinate is always guaranteed to be 1. Okay, so some other just review of slopes. See if you can remember this from previous years. The slopes of parallel lines are, if lines are parallel, their slopes are, the same or equal. Good. Okay, how about this one? This is the one that's a little trickier. The slopes of perpendicular lines are opposite, not just opposites, but they're opposite reciprocals. That's it, opposite reciprocals. Okay, so you have to flip the fraction and change the sign. Okay, so if we want to determine whether a pair of lines are parallel or perpendicular or neither one of those things, what's the only part of the line that we really need to know of each line? Slope. We don't need to know the y-intercept. All we need to know is the slope, correct? So if we look at, like in example 13 here, if we look at these two lines, let's make the first one our red line, and the second one we'll make our blue line. Okay, so if I want to find out if the red and blue lines, how, if they're parallel or perpendicular or neither, then I just need slopes. How could I come up with the slope of the red line? Okay, good. If I solve for y, I'm putting it into what form? Slope intercept, and that tells me the slope, doesn't it? Because if a line is in slope intercept form, the coefficient of x then is always going to be the slope, isn't it? Right? So that's all we've got to do. So what are the steps to solve for y in the red equation? Okay, subtract the 10x, right? So we end up with 5y equals -10x plus 5, and then what? Divide by 5. And I get y equals what? -2x plus, who cares? Do we even care what the y-intercept is? Do you? We really don't care, do we? All we need to know is what the slope is. Okay, now I would claim you can do that in your head. If you look at this, you could isolate the y, and if all you're trying to do is figure out what the coefficient of x is going to be, you guys can do that in your head. At this level, we subtract, we can already see we're going to get a -10x on the other side divided by 5. It's going to give us a -2x plus, I don't even care about the rest. All I need to do is keep track of that x term, right? So for the red line, m equals -2. What about for the blue line? If I isolate the y, I'm going to get 2y equals what on the other side? Well, -x plus 16. What's the last step to get the y by itself? Divide by 2 or distribute a 1/2 through, however you want to think about it. Aren't I getting y equals -1/2 x plus, who cares, right? Because all we need is the slope. Hey, Dan. Yeah, what's up? Yeah. Oh, yeah. Could I give you a call back? I'm in class right now. 3271. Awesome. I'll give you a call back after class. All right. Thank you. Bye. Exactly, because that's all they're asking. Right. So yeah. So based on the directions here, that's exactly it. Based on the directions. Hey, quiet, please. Based on the directions, all we're asked to do is find out if the two lines are parallel, perpendicular, or neither. We don't have to do anything else, right? So all we need are the slopes, and so we really don't care about the y-intercepts. That part's irrelevant. We just need the slopes. So the blue slope is -1/2. So which one is it? Let's do this. We'll go, so thumbs up is parallel, thumbs down is perpendicular, thumbs sideways is neither. Okay, everybody vote with your thumbs. What do we got here? Okay. Okay, I'm seeing some people starting off down, but they're adjusting and they're going neither. It's all, I mean, why, if people choose perpendicular, what are they probably seeing there? They're, okay, yeah, they're seeing reciprocals, but to be perpendicular, lines have slopes that are not just reciprocals, they're opposite reciprocals, right? We have to flip the sign and flip the fraction. Okay, and we didn't flip the sign. They're both negative. What is the answer then? Neither. Yeah, correct. It's neither. Okay, what about number 15 then? On number 15, if I, and just try doing this in your head. If I take the first line and I solve for x, solve for y, what's the coefficient of x going to be? Y, okay, it's going to be y equals x, right? So what's the slope then? 1, right? The coefficient of x in that case is just 1. So we get, what's that? Oh, it's already written down? Oh, okay. Whoops. All right. It's already written down. Okay, well, that's all right. I mean, but so wouldn't you agree you guys could do this in your head though? Right? This is mental math that I think you should try to do this stuff in your head, at least in class. I mean, this really helps your math if you can kind of start to move some steps around in your mind. So we get m equals 1 and m equals 1, so they're parallel. Okay, last one. What about this guy down here? Right here, bottom one. This one's not on your paper. Yeah. Mental math time. So let's try the red line. There's the red one. What's the slope? We're going to get y equals what times x plus, who cares? Three over two. Everybody agree? I'm going to get -6y equals -9x plus blah. And so -9 divided by -6 is going to give us positive 3/2. Okay, how about the blue line? If I solve for y. Plus, who cares? Exactly. So yeah, so based on that, we can see that those are perpendicular, aren't they? Because those are opposite reciprocals. Okay, 3/2 and -2/3. So they are perpendicular. Okay? Give me 1 to 5. Does that all make sense? Okay. Good, good.
Wait, so let's say m equals 3/2, right? And then the other m is just not negative 2/3? Like regular 2/3, would that be neither?
Neither.
Okay.
Yep.
Okay, gotcha.
No, I'm slowly losing my mind over X.
How do you think I feel in the hemisphere?
Okay, so click them if you're click them all close, please. Or I want you to click that close. So let's talk about the x and y intercepts. You guys all know what x and y intercepts are. If I asked you to identify the x-intercept for this function, what is it? Okay, but how would I write that as an ordered pair? -3, 0, right? Okay, and that's important. So the x-intercept has coordinates -3, 0. What are the coordinates of the y-intercept? 0, 4. Okay. And in fact, that's going to be a trend that's going to work for any x-intercept or any y-intercept, right? Every x-intercept has what in common? 0 y-coordinate, right? Every y-intercept has what in common? 0 x-coordinate, okay? So that is important because that allows us to do something really tricky. Here, I'm just going to just fill these in. These are just some vocabulary words. I don't want to get hung up on this right now. This is going to break our train of thought. There are some other terms that we frequently use interchangeably with x-intercept. Each of these has a slightly different flavor, and as we use them, we'll talk about why. Yes. They each are they're subtly different. So don't get sidetracked on this. You guys all know what I mean when I say they have a little different flavor, right? They're going to be used in slightly different contexts. Okay, this is where I need you to not be talking because we got to have our train of thought going here. So just write those in, forget about them for now. Know those words, but we'll talk more about them later. Let's get back to this intercept stuff though. So this gives us the fact that all x-intercepts have 0 y-coordinate and all y-x-intercepts have 0 x-coordinate is very, very useful to us because it gives us an excellent way to quickly graph lines. Remember when we graphed lines on Friday, we said our strategy for graphing lines is always the same. We're going to find 2 points because 2 points defines a line. And that kind of launched us into a little tangent, didn't it? 2 points defines a line. And so if I can just graph 2 points, I can always connect and extend to graph my line, correct? Well, we practiced graphing lines in slope-intercept form where we start with the slope-intercept as one point, or the y-intercept is 1 point. We use a slope triangle to create another point, and then we connect and extend. See, so there's another technique we can use here, though. We can take advantage of our knowledge of intercepts, and we could say, okay, well, to find the x-intercept of an equation, what could I set equal to 0? Why? Exactly, because I know that the x-intercept is going to occur when y equals 0, right? So I could always set y equal to 0 and solve for x. That's a great trick, right? If we want to know what the x-intercept is, we ask the math gods by setting y equal to 0 and using algebra to solve for x. And we use the corresponding trick to find the y-intercept. We would set what equal to 0 in this case? Set x equal to 0 and solve for y, right? How simple. Like, let's take this example. Here's a line. This one happens to already be in slope-intercept form, so it would have been pretty easy to graph, anyway. We could have started with a y-intercept of 50 and then used a slope triangle up to and over 1 would have worked just fine. But we don't have to. We could find the x-intercept, again, by setting what equal to 0? Y. Okay, so this is called the cover-up method. All we'd have to do here is I could just cover up the y term because it's going to be 0. The value is going to be 0 and solve the remaining equation. If I solve for x, what am I going to get? Careful. -25, right? Because I got to subtract the 50 to this side and divide by 2. But you can do that stuff in your head, right? So when we're finding the x-intercept, we automatically already know y is 0. Cover up the y term and solve, and I get -25, 0. Okay? To find the y-intercept, what would I do? Cover up the x term and solve for y, right? So if x is equal to 0, any number times 0 is what? Right, so that's why we can cover up that term. So I end up with y equals positive 50. Done. Okay. How'd I do it? Again, I just set x equal to 0 and solved for y. Right? And I got 50. Over here, I set x equal to 0 and solve for, or set y equal to 0 and solve for x. Okay, give me 1 to 5. See that trick? Not a big deal, right? Okay, let's try that. So if we do something like number 2. Okay, what would we do on number 2 here?
It's filled in for us.
Oh, it is. Okay. Okay, well, let's talk about how we would do that, right? If I wanted to find the x-intercept, really all I have to do is cover up the y term and solve. Now, what did they do? They cleared the fractions, which is fine. You can do that. That's okay to clear the fractions. I would claim you don't really need to, though, right? Because if I solve for x here, aren't we just going to get x equals -2 times what? How do I undo multiplying by -6/5? Multiply by -5, by the reciprocal, right? -5/6. Okay. So -2 over 1 times -5/6, if I multiply straight across, is positive 10 over 6, which is 5/3, right? So I solve for x. See how that works? Do you need to clear the fractions there? You certainly can, but I would say you don't necessarily need to, because one of the terms is always going to go away. So all you're going to ever end up having to do is just multiply by a reciprocal. Sure, it's a fraction, but multiplying fractions is easy, right? Take your pick. You could clear fractions also. Either way works. Give me 1 to 5 on that. You guys see why you don't need to clear fractions there necessarily? Okay. How would I find the y-intercept? Set the, right, so I cover up the x term, in other words, right? I'm going to set x equal to 0, which means I just cover up that x term, and I get y equals 2. Easy. What's up?
Next Friday we have the assembly. Would
Mhm.
you like to be a judge?
I might not be here that day.
Okay.
Yeah.
Let me know as soon as possible.
Okay.
Thank you.
Yeah, you bet. So I get y equals 2. No big deal, right? Okay. And then to graph this thing, piece of cake. All I've got to do is graph those two intercepts and connect and extend. So if here's the x-axis, there's the y-axis, I get 1 point at 0, 2. I get 1 point at 5/3, 0. Now, we don't write mixed numbers in high school, but we think in terms of mixed numbers. 5/3 is what as a mixed number? 1 and 2/3, right? 3 goes into 5 one time with 2 remaining, so 1 and 2/3. So then I'd go 1 and 2/3, 5/3, 0. There's my 2 points, connect and extend, and we got it. Okay? Let's look at one more of those. Here's a super easy one, right? Super easy. Let's look at number 4.
Can you go back to the second number 2 actually?
Yep.
Do you have to take, so you took the 5/3 and you took it and shrunk it into 1 over 2/3, right?
Okay,
Turn it
so
into a mixed number.
yeah. So here's what I did. I mean, I'm going to take that 5/3, and I'm going to when I want to only because I'm graphing it, right? I have to know where to put my ordered pair. So I think of 5/3 as just being 1 and 2/3. So when I graph it, then I know where to put the point. I go over 1 and then I go 2/3 of a, right? That's the only reason I do it, was so I knew where to put the point. Okay. Yep.
Oh. Yeah, I was thinking that.
Okay. Do you guys need? You haven't probably done that in a while. Here, just practice 1 or 2. What is this? Tell me what this is as a mixed number. Everybody agree? 2 3/5. 5 goes into 13 2 times with 3 remaining over the 5. Okay, right? So what is 29 sevenths? Right? 7 goes into 29 4 times, and what remains over the 7? How many remain? 1. Okay. So right, so if I were graphing this, if I were graphing a point that had like an x-intercept at 29 sevenths 0, how do you know where to put the 29 sevenths on the graph? You got to think of it in terms of a mixed number, so you know it's going to be a little more than 4. That's the only reason. Okay.
I was thinking of it in terms of both lines for a second. I was like, wait, both axes, and I was like, no.
So what about this one? Let's do this one super fast, right? Let's graph this line super fast. If I want to find the x-intercept, what's it going to be?
That's not mine.
What do I cover up to find the x-intercept? The y term. I set y equal to 0. So if 4x equals 8, x equals 2. There you go. So we've got a point at an x-intercept at positive 2. Okay, if I want to find the y-intercept, I cover up the 4x, right? I cover up the x term. So negative y equals 8. That means y equals negative 8. Okay, and so we've got another point on the y-axis at negative 8. And I just connect and extend, and I'm done. Okay? Got it? Everybody good there? Let's do one more, and then we'll call it good. Number 6. Okay, so I want to find the x-intercept. Cover up the y term. Okay, so I get 3/4 x equals negative 2. Take a second, just think here mentally. What is x going to equal?
Is it negative 3 eighths?
What am I going to do? Okay, right. So x is going to equal, I already have a negative 2 over 1 on that side. I'm going to multiply each side by what to get the x by itself? 4/3. So I just multiply fractions straight across. So negative 8/3. Okay? So there's one point. Y equals 0, x equals negative 8/3 is a mixed number that is 2 2/3. Okay, so I got to go back 2 2/3. To find the y-intercept, I'm going to set the x term equal to 0. Negative 1/3 y equals negative 2. So what's y going to equal? Because what do I have to do to undo multiplying by negative 1/3? Multiply by the reciprocal, which is negative 3. So y is going to equal negative 2 times negative 3, which is negative 6, right? So I get the ordered pair 0, 6. You're right, positive 6. 0, 6. Negative times negative is positive. You're right. Okay, so 0, 6 is right there. And there's my line. Yeah, it's not for a change. Okay, good. Okay, did I need to clear fractions? Again, I really didn't, right? All I'm doing is multiplying by a reciprocal when I cover a term up. Okay, I think that's good. You guys can work. 2-2. It's up there, ready to go. Have at it.